Thank you very much. Well, this is my first time to New Zealand, and so far I think it's beautiful, and everyone's very nice. But I guess there's a bit more to that decision than that. I'll have to think about it. Okay, so I'm going to be talking about Kubernetes security low-hanging fruit, meaning like where can you get started? What's the sort of easy wins? Introduction sort of covered it all, really. My background's more from the development side, although nowadays I do Kubernetes and security, obviously. We're based in London. I've been there for 12 years originally. I'm from the West Island, as I heard it called today. It's a new one for me. So the kind of central premise of this talk is that if I think I can relate to, I'm sort of pitching at an audience of a former me, if you know what I mean. I don't know if you ever do that. But me coming from a developer background, not necessarily always having a security expertise or focus, I often found security to be a daunting subject. And I think that's often due to the way, it is really important, so I think it's not so strange that people present it with a lot of like fear, and if you don't do this, then everything's really bad, because a lot of bad stuff can go wrong. I don't mean to say that that's not the case, but I think when it's all thrown at you at once, and you sit there and you think, oh, I'm not doing any of these things, things must be terrible. Where do I get started? How do I start on this journey, I guess? This talk is designed to address that. So with Kubernetes, there are a lot of security things you can tweak and do, but where to get started. So first I'm going to talk about and also where to get started in terms of there are a few small things that you can do that will address like a large part of the threat landscape that you face. You don't necessarily need to start out defending yourself against nation-state actors and things like that. So first of all, I'm going to talk about a bit of background, talk about container security in general, and how an attack on Kubernetes workloads or clusters might proceed, because I think that's useful background for why you need to do all these other things. If you just have someone telling you do this, do that, without sort of knowing why, it's less motivating, I guess. And then I'll give you the recommendations at the end. And finally, I will put in some stuff at the end for how I think you can improve your organization's security in general, which is not only about Kubernetes. Okay, so a bit of container and container security background. Containers versus VMs, you've probably all seen diagrams like this one. If you ever, hands up when you were first introduced to containers, if you were told they're like lightweight VMs. Anyone get told that? Yeah, it's annoyingly prevalent. I'm same here. Actually, in case you don't know, containers are just processors. Nothing particularly special about them. There are obviously some features that make them different from other processors, but they're just processors. That means that we're making an isolation trade-off when we make a transition from VMs to containers. We don't have a hypervisor. On the right-hand side, our processors are running directly on a machine. They're just processors on a machine. And so we have less isolation, but we make that trade-off because we get some other benefits as well. Containers will have their own file system and network, so they can't see each other's traffic, and they can't see each other's files, and to some extent can't see what other processes are running on the system. But they do share a kernel and memory, so this trade-off is fine, it's good, but don't multi-tenant. I've got an asterisk there because there are ways you can do that, but that's not what this talk is about. So isolation trade-off is a point I want to make. The containers are just processors. Okay, so when we have our containers, our processors running in Kubernetes, how does that look? What are the isolation boundaries? So we have pods, which anyone who's worked with Kubernetes probably has come across. The fact that pods are one or more containers that should always be scheduled together. Every container has its own mount and PID namespace. That means they can only see their own files, and they can only see their own processes. They can't see other ones. I've got an asterisk next to PID there because in newer versions of Kubernetes, there's a beta feature which is turned on by default where containers in the same pod can see other processes, which is a bit mad to me, but which means it's another topic. It means you can also see each other's files in it with a few tricks around the proc file system. Don't worry about that. Containers have their own mount namespace. They can only see their own files. Containers in the same pod will share a network namespace. That means they have the same network adapter. Containers in a pod can talk to each other on local hosts. Okay, so you wouldn't put things in a pod that you don't want to be able to sniff traffic, right? The next sort of isolation boundary is the host itself, or node as I've called it here. On that, you have the container runtime, such as Docker or something like this, and you have the kubelets. On each host has its own kernel and RAM, of course. So you can sort of start to see the story here, where if you break out of these various isolation boundaries, you have access to more stuff. And this is kind of what an attacker would like to do when they break into a containerized workload. So if you can get access to the container runtime, then you can presumably run containers on the host. Maybe you can even run them with high privilege. That would be a nice thing to be able to do for an attacker. If you can talk to the kubelet, you might be able to get some secrets about the workloads that are running. The next sort of isolation boundary is to go from the nodes up to the control plane. By control plane, we generally mean the Kubernetes master and etcd. Hopefully that's not the same thing, although in some cases it is. If you can get access to control plane, then you can talk to the API. Depending depending how powerful the credentials you have are, you may be able to do more or less things with that, but that's the next kind of attack goal. And ultimately, you'll be able to maybe run workloads, fetch secrets, or if you can get into etcd with right access, you can do whatever you like in the cluster, assuming things aren't encrypted. Lots of caveats here, I'm just touching it lightly. So these are the isolation boundaries that we have in the cluster. Okay, so before talking about how an attack might proceed, a few bits of terminology. So a vulnerability is an application that has some sort of flaw, or a component that has some sort of flaw. It might be a bug, it might be a design flaw, it might be a lack of some control or something like that, that may or may not be exploited, it may or may not be known about. An attack is when one of those vulnerabilities gets exploited. So it might be a security bug in an application, or it might be a vulnerability in a dependency the application uses, and it gets exploited. That's what happens in an attack. And then that component that has been in which the vulnerability has been exploited is considered compromised, so that you have that component is compromised. The first component that an attacker breaks into within a system, so it might be like a web app or something on the internet, so that obviously it's got a port open to the internet. When they break into that and compromise that, then that becomes their foothold. So it's like, maybe like in battle terminology, like getting a beachhead or something like that, getting in somewhere, and then you want to go into the rest of the system. And that's called pivoting, going from your foothold into some other place. All right, so you can already start to think about maybe a web application sitting on the internet might have some vulnerability in it. Someone breaks into it. What kind of requests can they make from there? We'll start to explore what they might want to do there. Privilege escalation is another useful term. It's like when you become root, or you somehow go from one level of privilege to another. It's kind of clues in the name, I guess. Okay, so we're going to look at a workload compromise and cluster compromise. So how might a Kubernetes workload compromise proceed? So you might have some application vulnerability in, so for example, if you remember the Apache strut, sorry, I've jumped ahead of myself. If you remember the Equifax leak, that was by exploiting a vulnerability in Apache struts. So some vulnerability in an application maybe allows someone to put, so something like putting drop tables in a search box, right? That's exploiting some bug in some code or in a dependency. And then maybe they can use things like that to gain a shell, for example, inside a container. Now remember from the earlier slide, the containers have their own mount namespace and PID namespace. Once someone gets a shell inside a container, then all they can see is the files that exist in that container image. And they can't see other processes that are running on the system. However, there are sharing a kernel and memory and things like that. One attack vector might be to exploit a kernel vulnerability and try to access shared memory on the host. Also, they might want to try to discover other workloads. So just as your web application or a front-end API or whatever might be able to make requests to a database or to some other services, so too can the attacker once they break into that container. So you want to start to think about, the attacker's going to be thinking about, okay, what else is running in this system that I can try to connect to? Hopefully for them, not for us, they'll find something with sensitive data that isn't sufficiently secured, and they'll make requests to it. That, again, is something like this, grossly oversimplifying it, but something like this happened in the Equifax leak, where a front-end component was exploited, was attacked, and then ultimately, through various steps, they were able to grab sensitive customer data and credit card data and exfiltrate it across the internet. Step 3, they'll try to, once they get that data, they'll try to send it out across the internet. So if we can lock down these sort of steps, then we can limit the damage that can be done when something is inevitably compromised. Then they might want to pivot to compromise the host. They might have some exploit that allows them to break out of a container through some kernel bug or some poor configuration of the container runtime. They might also, we'll look into this on the next slide, they might also want to look to reach the control plane from there and see if they can attack either the kubelet or the kube API, or maybe even etcd. Okay, so now we're starting to look at the cluster compromise examples, which may come from a workload compromise, or they may come from some other source. Let's imagine that some attacker has gained access to a node host, like an actual host. They will want to be able to run containers. Hopefully they can run containers in privileged mode, and then they're in an effectively root on your system. It's Dan Walsh, I think his name is, from Red Hat, often says in his talks, running a privileged container is even worse than being root on a host, because that user never logged in and there's no audit trail. It may or may not be easy to do certain things via that method rather than just being root, but it's certainly very bad that we don't have the audit. As Scott mentioned earlier, having a Docker socket access in a container is as good as root on the host for the same reason. Docker doesn't have role-based access control on the API. If you can access the API, you can run whatever you want, right? There are things you can do about that, but just keep it high level. Potentially, a container workload will have a service account token, which is effectively, just when you use kube control with Kubernetes, you have a credential to talk to the API. Workloads can have the same. They're called service tokens, service account tokens. They are for things like operators, anything in the cluster that might want to affect the Kubernetes cluster or talk to the Kubernetes cluster, whether it be a monitoring component or some sort of operator. An attacker who breaks into a container will look for that token and then try to use it to talk to the API and see what it can do. They can use something like kubecontrol auth can I, and we're like, can I get secrets? Can I create pods? They were delighted to find that they could do those things. It's a reason to use role-based access control, right? God forbid it's a cluster admin or something bad like that. But this is what they're going to try to do. If they're on the host, as we're positing here, they might try to get the service account token for the kubelet. The kubelet sort of runs containers on the host on behalf of the API, you could say. It needs credentials to talk to the API to do that. Those credentials are pretty powerful. They will allow them to get secrets, maybe not all of them, depending how you've set it up. They will want to do that. So good reason to lock down kubelet as well. They may have an exploit for the Kubernetes API. When I wrote these slides, I was like, there was one a while back. Haven't heard of one for a while, but there was one like yesterday. So in the Kubernetes API custom resource definitions, Scott told me about this morning. There's a CVE out at the moment, which you should take a look at. Anyhow, who knows, there may be loads of others out there in the wild right now being exploited. And they may attempt to access etcd ultimately. Okay, so just to give you an idea of the way they would try to progress their attack. There are a whole bunch of areas in which we can put something in place to prevent various things like this. I'm going to quickly run through the kind of things you could do at each of these levels. When presented like this, and they're all kind of thrown at you, it's a bit daunting. Like I said at the end, I'll pick out what I think is the low-hanging fruit that you should start with from all this. Okay, supply chain. This means all of the code and dependencies that went into our application. So our application and its dependencies, and our dependencies, all that sort of stuff, our build tools, all this sort of thing is part of our supply chain. Ideally, we want to be able to ensure where things come from, that they haven't been modified. That's a bit of an aspiration, something to work towards. To suggest that you need to be able to do that completely right now is not what I'm suggesting. You can do that by whitelisting source of dependencies or individual dependencies. So if you're using something like NPM, you might say, we're only allowed to use these modules. That would be, as you can imagine, that would be a bit of a mission because we use so many modules in NPM, right? There was a good talk out recently at KubeCon called Securing NPM Install or something like this, where a team that's working has done some great stuff around isolating JavaScript. Anyway, you can also in the supply chain you can scan all the dependencies in your application, or basically everything in your container image, for known vulnerabilities, so that at least you're aware of what vulnerabilities your dependencies have, and you can mitigate, work around them, swap them out, that sort of thing. You can also protect Git branches, so that you can make sure that things don't get merged without proper scrutiny, and also commit signing. So you may or may not be aware that Git's Merkle tree structure is about integrity. It's not about authentication or authorization. It's relatively trivial to pretend to make a commit to someone else. There's a blog post out there where someone pretended to be Linus Torvalds. Not a man I'd want to annoy, although he's nice now, right? Also, at the container image level, we want to basically minimize the attack surface of what's available in our image. So I'm going to have to go a lot faster than this. So the less that's available to that attacker once they get a shell in your container, the less damage they can do. We can also ensure the veracity of our images by signing them, and we can do various other things as well. Application security stuff is beyond scope here, but you probably want to do some sort of static or dynamic analysis of your code. But that can have a lot of false positives. Make sure you get a good solution there, or best not to do it. Otherwise, just people will circumvent it and ignore it. Pipeline controls how you manage your secrets. Don't put them in Git unless they're encrypted, that sort of thing. Most important here, you want to make sure that you can deploy very quickly and easily and with little friction, not just because that's nice to deliver quickly, but because if with the myriad of dependencies that we have, we can't. It's an aspiration to control our supply chain that strongly. It's more important to be able to respond quickly when you need to patch. And if you discover a vulnerability and you're like, okay, let's patch. It's going to take us a few weeks. This is not a good situation to be in. Agility is your best defense there. But also you could use a GitOps style pull-based model. We had a few people talking about this today. This helps to protect the credentials that are in the pipeline. And obviously locking down your CI server. Linux security features, I said earlier, containers are just processes. They're processes isolated by C groups and namespaces. Namespaces give us some isolation. C groups allow us to prevent noisy neighbor and fork bombs and all that kind of thing. We can use things like SC Linux, AppArmor, what have you. But this is not necessarily even the most basic things we can do. We'll come to that in a second. The cluster level role-based access control will ensure that when your service account tokens are eventually compromised, that if they can do very little, then the attacker can do very little. There's a standard set of emission controllers to block deployments in Kubernetes, and the default set is pretty good. You should at least pay attention to which ones you've enabled and which ones you haven't. And secure your container runtime and how you've exposed and configured your kubelet and API ports. Put your etcd on a different host than the master, so that if the master's broken into, it doesn't mean etcd compromised. It's the most sensitive part of the whole system is the etcd. The network level, you want to be able to control what can talk to what. So if something breaks into the front end, you don't want them to A, make queries for the database, and B, exfiltrate their data out onto the internet. Network policy is our friend to protect against that sort of thing. And we can do that with mutual TLS and cryptographic workload identity using something like Istio. We can also just use regular Kubernetes network policy. If we're using service mesh, we should use both of those. Infrastructure and runtime, common sense stuff beyond the scope here, really. Okay, so with all this, where do we start? It's complicated and daunting. So here's what I think is the low-hanging fruit of Kubernetes security. Firstly, minimize your container image attack surface. This list of tools here, if an attacker finds any of those, when they get a shell, they're going to be delighted. They can download their tools, they can build tools, they can do whatever they like. Use a base image, something I'm not suggesting you have to use distroless, but if you want one recommendation, it's a good one. If you can build images from scratch, do that. Distroless images will not have a shell. You can't even exec into them, which is great. Role-based access control, it's one thing for me to tell you that you should do it, but it can be daunting to know how to configure it for your organization. A great place to start is the GKE documentation on how to split up the roles and groups for your team. It's not specific to GKE, it's a good place to start. Network policy, just like that slide a few slides ago, whereas if you break into the front-end service, you shouldn't reach the database or exfiltrate data. Speccing that out for your microservices is really important. Make sure you're aware of do container image vulnerability scanning. Make sure you can release quickly. should put C group and memory limits on all of your processes so that they're not, so that you have accurate scheduling, but also so that they're not going to read up all the resources and you're not vulnerable to like denial of service type attacks within your containers. The default set of admission controllers is documented. All these links, by the way, I've got a link to the slides at the end. All the links you can find in the slides. So the recommended default set is a sound place to start. The admission controllers, and use the CS benchmarks for things like Docker and Kubernetes. Pod security policies is an admission controller that can block deployments that don't meet certain security requirements that you might specify. Again, writing those is kind of challenging, but Tim Allclair has written one that we can start with. It's quite good. Okay, I think I'm just about out of time, but just very quickly, in terms of improving your organization's security, you might say DevSecOps. I hate all these buzzwords, all right? Essentially, bringing security and development teams together, just like we've been bringing dev and ops teams together. Your security department in an enterprise is probably understaffed, under-resourced, and they probably really care, and all they can really do is set rules that they hope you follow because they don't have enough resources, right? Sit down, talk to them, build bridges, automate the things that they care about. They will be delighted. And start to think about these things when you're designing your services, okay? So I'm building a service that talks to a database. It's dealing with customer data. How sensitive is that? What would be the business impact if that was compromised? This is essentially threat modeling. You can do some basic stuff around threat modeling. When you design your services, capture it in your README somewhere, and this is a good start. From that, you can build your network policy and all that kind of thing. So how might threat modeling proceed? We say, what are we building? Then when we're looking at the kind of things that can go wrong, we can use various systems like Stride, OWASP Top 10 to think, what if this happened to my service? What would happen? Draw them up with attack trees, how that methodology would progress, decide what to do about it, capture that document, iterate, share it with the team. They're going to be like, oh, you forgot this, and then just go around again. It doesn't have to be, you don't have to use data flow diagrams, you don't have to use any particular format, just do it, just talk, just write it down. That's the most important thing. Draw up a table saying, this service has this data, what if this, who might be interested in it, what are their capabilities. You don't care about protecting against nation-state actors unless you're doing government security projects. Maybe start at what's the most likely and what's the most business impact and what you can spend the time to fix, basically. Okay, so security, I know it's daunting, but you can start with the basics. Those slides will tell you, that slide 2 slides ago will tell you what I think is a good place to start. And the rest of those slides will provide like the next steps, but do at least start there. And make security part of everyone's job in your organization by talking about it when you design your services. Thank you very much.
Thank you, Luke. Any quick questions?
When it comes to container isolation, what are your thoughts on the option of using something like Kata containers? So you add a thing like largely around where
Yeah, so the question is, when it comes to container isolation, what about using something like Kata containers? There are various technologies such as Kata containers, K-A-T-A, that will give you VM-like isolation per container. I think it's great. But if you're running trusted workloads for your own applications that is not highly sensitive data, it doesn't matter quite so much. But if you're thinking about doing any kind of multi-tenanting, whether it be between teams or between products, or especially between customers, then you absolutely want to go down either that route or even have full host isolation. Don't let any 2 customers share the same host or 2 teams, things like that. But yeah, I think it's very good to use things like that.
Okay. Thanks, Luke.
Welcome.